Before we design wallet-based onboarding or KYC, we need a shared language. In this topic, you'll pin down what PID, electronic attestations of attributes, verifiable credentials, presentations, trust lists, and assurance levels actually mean for your architecture decisions. You've already seen why eIDAS 2.0 matters for digital onboarding and KYC, and you've met the main players in the EUDI Wallet ecosystem. Now we're zooming in on what those players actually exchange: identity attributes, credentials, presentations, trust metadata, and assurance levels. Once these terms are clear, we'll turn them into a journey. End-to-end wallet flows, checks, and system responsibilities in the architecture view. In regulated onboarding, words are design decisions. When we say credential, attribute, or assurance level, each term implies who issues the data, how it's stored, how it's presented, and how trust is checked and logged. If teams use these words differently, requirements drift, integrations break, and KYC evidence becomes much weaker. Think of person identification data as the bedrock of a digital identity. It's the legally reliable facts about a person, like their name, birth date, and official identifiers, that rarely change. In an EUDI wallet journey, everything else layers on top of this: address, age proofs, professional status, risk indicators, and finally the customer profile. Architects must keep PID distinct, because it's the authoritative anchor that other attributes depend on. In a wallet-based journey, PID starts life at a trusted identity source, like a government register or national ID system. The user then imports that PID into their EUDI wallet, which becomes the primary way they control when and how it's shared. When a bank or KYC platform requests it, the wallet presents PID, and the relying party rigorously checks the issuer, the signature, revocation status, and whether it actually meets their regulatory policy. As an architect, treat PID as a governed object, not just fields in a table. First, decide the absolute minimum attributes you need to satisfy onboarding and regulation. Then design clear mappings from each PID field into the customer master, KYC cases, and audit evidence. Define matching logic upfront, how you handle nicknames, transliteration, and duplicates. Finally, favor derived or tokenized values so you retain only what's necessary, while keeping evidence verifiable. Core identity answers one question: who is this person? Electronic attestations of attributes answer everything else that matters for a decision. Is this person an adult, at this address, with this degree, this license, or this membership? Each claim can come from a different trusted issuer, like a government, a university, or a professional body. During onboarding, you reuse these digital attestations instead of collecting documents, and you keep identity proofing separate from eligibility and risk checks. Take a digital bank onboarding a new customer. It doesn't actually need your full birth date, it just needs to know you're over 18. For address, it only cares that a verified residence exists, not every previous address. If you apply as a lawyer, it wants proof of that license. And for a student account, it simply checks that a valid student status attribute is present. Under eIDAS 2.0, think of qualified attestations as hard evidence and non-qualified as softer indicators. Qualified attestations come from regulated audited providers, so you can often plug them directly into high-risk or regulated workflows. Non-qualified ones aren't useless. They just shift more work to your side. You may need extra checks, compensating controls, or limits on use. Whatever you decide to accept, document your policies and rationale for audit and consistency. A verifiable credential is like a sealed envelope of facts about you, signed by a trusted issuer. Inside are claims, who issued them, who they're about, when they're valid, and a cryptographic proof that nothing was changed. These credentials can carry PID, attributes, or licenses in your wallet. You choose when to present them, and each relying party must verify the proof before using the claims for KYC decisions. Imagine proving you're over 18 without handing over your birth date. That's what a verifiable presentation does. It packages just the claims you choose, proves you control them, and lets the relying party validate them. Nothing more, nothing less. So think of a credential as a durable asset and a presentation as a disposable message. The issuer's credential lives in the wallet, with lifecycle rules like issuance, expiration, suspension, and revocation. It's reusable across many relying parties. A presentation is freshly generated from that credential for one specific request with explicit consent, tailored disclosure, replay protection, and auditable evidence of what was shared, with whom, and why. Trust lists act like a reliability API for your onboarding pipeline. They answer 4 questions automatically. Is this issuer officially recognized? Is the service type allowed? Is the certificate still valid? And does it match our policy? Instead of a human checking PDFs or websites, the verification service calls the trust list, gets structured metadata, and makes a consistent decision. When trust list checks fail, the credential might be technically valid, but you still say no. Assurance levels turn raw credentials into a risk decision. First, the system receives a wallet presentation and verifies the cryptography. Next, it checks whether the issuer is trusted and the credential is still valid and fresh. Then it evaluates the assurance level against the product's KYC policy. Low-risk cases can be auto-approved, medium risk goes to enhanced review, and high risk or weak evidence is rejected, with every decision logged for audit. You now have the vocabulary to talk precisely about EUDI Wallet onboarding. PBDIG gives the core identity. Attributes add context. Issuers bundle these into verifiable credentials. Users share them as presentations. Relying parties then apply trust lists and assurance policies. Next, we turn this language into an end-to-end architecture.